In the previous video, we talked about going from offensive and defensive power ratings to these numbers like this 5.8 for number of points expected to be scored above average. Eventually, and especially in the next video, what we want to do is talk about how do you go in the opposite direction. If you know how many points the team is expected to score above or below average, how can you go from that information for many different games to offensive and defensive power ratings and also home field advantage? So what eventually comes up is it's like we're trying to solve a system of equations like this here. I've written down the first 5 equations, and in total there are 65 unknowns, 32 offensive power ratings, 32 defensive power ratings, and 1 home field advantage. And let me remind you where these kind of numbers come from, like this 5.43. They're all stored in this df sub data frame that we made in the last video. So for example, where does this Philadelphia minus 1.57 come from? Okay, it comes here because in this Atlanta versus Philadelphia game, then the spread and the total for that game tell us that Philadelphia is expected to score 1.57 points below league average. And so rather than talking right away about how do you try to solve so I shouldn't say solve, I should say how do you try to find what 65 values of the unknowns come closest to producing these outputs? Okay, this 5.43, negative 1.07, etc. And there's no exact solution. And rather than talking about that right away, I want to talk about a very similar thing, but with a much simpler system of equations. This is just 2 equations in 3 unknowns. And your intuition should be that since there are more unknowns than equations, there will be infinitely many solutions. But yeah, that's the generic expectation. But if I choose the numbers carefully, then there might be just 1 solution or there might be no solutions. And here I've chosen the coefficients so that there are no solutions. And originally I started to record this video where I was like building up this plot 1 line at a time, but it was just getting too long, and that's not really the point of these videos. So I'm just going to jump right into having a plot. So let me evaluate this, and let me show you what it looks like. So I've made this data frame called df random, and let me show it to you. So points is like how many points I'm going to draw on the plot. ABC, that's like some random values of these variables up here, of these unknowns ABC. And then I've set it up here so that the X column, that corresponds to 1 times A minus 0.5 times B plus 2 times C. And Y, it's the same, but for the second equation. So negative 2 times A plus 1 times B minus 4 times C. And what we're hoping for is to get the values 2, negative 1 out of it. And so let's try looking at this. So let me delete df random and let me draw it using Altair. And so at this thicker point, that is what we're trying to reach. So we want x equals 2, y equals negative 1. Okay, the analogy for that and what we're eventually going to do is we're going to be in some big 544 dimensional space, and we're going to be trying to get the point 5.4, negative 1.1, 1.9, etc. Okay, but we're never going to be able to visualize that. Even just in 3 dimensions, it's already getting hard to visualize. So here I want to do it in 2 dimensions. So here, this is the point 2, negative 1. And here, this is the output of those chosen values of ABC. And we're curious, how close can we get to this actual value? And so nice thing about how I have this set up is if I ask for 5 points instead of 1, okay, then here it draws 5 points. Okay, and let's try it again. Okay, here it draws 5 points. Let me do it one more time. Hey, here also it draws 5 points. So let me add some customization to this plot. Let me say tooltip equals ABC and run it again. So now for each of these, I can look at it and say, what were the values of A, B, and C that produced this point? And in general, for any given point, there are going to be infinitely many values of A, B, and C that produce that, at least of the possible outputs. And then it turns out there is no value of A, B, and C that produces this point. So don't worry about that 0, 0, 0. That doesn't mean anything. And let me also add some color to this. So let me build it up and then I'll put it in here. So let me try to find what is the distance from this point. Okay, for example, from this point here, what is the distance from that to our target point of 2, -1? And so how can I find that? Well, I'm going to apply a function. Okay, a lot of times when I apply something, I use map, but that's when you're applying it to a series. If you're applying it to a whole two-dimensional pandas data frame, then apply or apply map are what you want to use. And I'm going to specify axis equals 1 that says I want to apply this to the rows. And then what's my function going to be? Well, the input is going to be a row. Okay, I could call this anything I want. I could also call it x, but if I call it a row, I think that makes it easier to visualize. And let's look at what df_random looks like. So the input is going to be a row like this. And then I want to know how far is that point, so the x and the y of that point, from our target value of 2 and -1. So the formula for distance is square root of the square of the distance between the x's. So I can say row bracket x, and then I'm trying to get to 2, -1, so that's why I have this -2. So the distance of the x coordinate from 2, oh, and I was about to make a mistake by doing this caret for exponent, but in Python you have to do star star for the exponent. Okay, and then it'll be the same thing for the y coordinate. And then minus -1, okay, because that's the y coordinate we're trying to get to. And let's see, have I made any mistake? Hopefully not. Let's look at it. And what I'm hoping this outputs is some length 6 pandas series of distances. The very last one should be 0, because the distance of this point to what we care about is 0. The second to last one should be not a number like this, and the first 5 should be some positive numbers because they're distances. Let's check it. Okay, yeah, that looks good. And so now that I trust that I've made that in the correct way, let me cut it and put it back up here. And I'm going to make a new column in df_random called dist for distance. Okay, and let's look at df_random again. So now there's this distance here. And let's see, I can delete this one. And then let's add distance to the tooltip. And so now if I hover my mouse over one of these points, it says this is 4.2 units away. This one's pretty close. It's 1.4 units away. And we can make it a little more fun by adding some color. So I can say for the color, and then I can never remember the syntax for this, so I've just opened up this page in the Altair documentation. So I want to use some syntax like this. So let me just paste it, and then I'll make the changes I need. So instead of species, I'm supposed to say what column in my data frame is going to choose the color. Okay, and I'm going to choose the distance column. And scheme, I could use dark. I'll show you what that does. But I don't find that one to be so nice. So I looked up in the documentation for different options, and I liked this turbo. So the more red the color is, the further the distance. The more blue or dark it is, then the smaller the distance. Okay, that's pretty good. Let me get rid of this df random. And let's try it with more points. Let's try it with 20. And so you can see that no matter what values of A, B, and C I choose, they're always lying on this line. And it's going to be something really similar in this complicated expression. No matter what values of the 65 variables we choose, well, it's not going to be on a line, but it's going to be on some at most 65 dimensional, and I think it's more like 63 dimensional subspace of this big 544 dimensional space that we're trying to solve. And so, like, why does there exist a best possible value? Well, the reason is because there's always some closest point on whatever our like linear subspace is to the target value. Here, there's always going to be some closest point to this 2 comma negative 1 point. Okay, looks like it's something like this. And so let's see how to use scikit-learn in Python to find what is one possible values of A, B, and C that gets us as close as possible. So we imported this thing called linear regression, and I generate a new linear regression object by using this syntax with the empty parentheses on the right. And I'm also going to say fit intercept equals false. So that is like, yeah, for the way I'm presenting it, that makes a lot of sense. For a common way of presenting linear regression, then you're really trying to find a line, which is like an mx plus b, and the intercept is like a b. So you could imagine, what if instead of all of this stuff, I also had a like plus intercept in each of these equations? Okay, but we don't want to do that here. If I did that, then suddenly there would be a solution. And back here, the reason we don't want to add some intercept is because if you think about it, if you have no offense, no defense, and no home field advantage, then the output should definitely be 0. So how do you get 0 as the output? You don't have an intercept. Like in the y equals mx plus b syntax, how do you make it go through the origin? Like input 0, output 0, you have no plus b. So yeah, I use this fit intercept equals false. And now I want to say, like, what is the system that we're trying to solve? So it's, let's see, maybe I'll copy and paste this so that I can look at it while I'm making it. So let me go back here and make a markdown cell and paste it. And so let me make a coefficient data frame. And so this is going to hold the coefficients like 1, negative 0.5, 2. So this is going to be a pandas data frame. Its index is going to be length 2 because there are 2 equations. And then its columns is going to be list ABC. So that's just a shorthand way of saying column 1A, column 2B, column 3C. And then I'm also going to have a target column. And let's see if I made it correctly. Okay, yes, that looks good. And so inside the 0th row, I'm going to put the coefficients and the target. So this is going to be 1, negative 0.5, 2, 2. And let's look at it again. And now let's do the same thing. And we'll have an automated way for doing this. We won't have to type in 544 of these when we're doing it for the NFL games in the next video. And so I wrote these in a different order just to sort of confuse you so you couldn't see that one was a multiple of the other. So we do -2 for the A coefficient, 1 for the B coefficient, -4 for the C coefficient, and -1 for the target. Okay, good. And now inside this linear regression object, I want to say, what are the coefficients? So here is one way to get that. I can say df coefficients, and then I want to drop from that the target. And if I just try it like this, I'll get an error. It says target not found in the axis. And that's because I need to say, look in the column names, don't look in the row names. So I do that by saying axis equals 1. So still get an error, but a different error. And so now I'm going to say, what is my y values? Like, what are my desired outputs? That's from the target column. Okay, looks like that worked. And now we can find the coefficients. Let's look at them. And so let me go back up. Let's see. Maybe I want to copy and paste this so that the notebook can be evaluated without getting an error. So let me evaluate this again. And let me remind you what df random looks like. And so I have these two weird columns at the bottom. One is for my exact point. Okay, this 2, -1 point that doesn't come from any A, B, and C. And the reason I left this second to last column blank is because in there I want to plug in my values that I just found using linear regression. And so this is supposed to be, these are some values of A, B, C. Okay, I mean, they won't be unique. There'll be other values too that give us this exact same X and Y. These are some values of A, B, and C that get us as close as possible to the desired X and Y. So let's see, where should I put this? I guess I want to put it up here before I define X and Y. So let's say df random.loc points. Okay, so for example, here points was 20, and I'm trying to put it into this second to last row, okay, which has index name 20. And here's what I want to put in the ABC column. And what do I want to put there? I want to put this reg.coef, okay, that is supposedly my best possible values of ABC. So watch how after I do this, then the second to last column should suddenly have A, B, C, X, and Y filled in. So I told it what A, B, and C were, and then it should compute X and Y. So let's see if I did it correctly. So I didn't get an error, so that's a good sign. And so see how the second to last column now has some A, B, and C. And so looks like X equals 0.8 and Y equals -1.6 is as close as we can get. And let's try plotting it again. Oh, and maybe I'll also add size to the bottom here. So this line was saying, make our special 2, -1 point, make that triple the size of all the other points. Okay, let's do the exact same for our second to last point. And so when I evaluate this or when I display this again, every line should change except for the bottom two. The bottom two should stay the same other than the size. So let's check. So hopefully the bottom two stayed the same. Is that, yeah, looks like the ABC stayed the same in this bottom one. And so now let's try plotting it again, and we should see two big points. The black point, which corresponds to like the output that we were trying to get, and then another point, which I think will be blue, and which is like as close as we can come using A, B, and C, and where we found that A, B, and C using linear regression. So let's check. Okay, and so let me print out again this coefficient that we found using linear regression. So 0.15, negative 0.07, A equals 0.15, negative 0.07. So you can see how using linear regression, we found this point that's as close as we can possibly get among all of these outputs to the desired output of 2, negative 1. Okay, yeah, that's all I'll say in this video. And in the next video, we'll go back to this system of equations here. This system of 544 equations, and we won't try to visualize it or anything. Instead, we'll just, like step 1, we'll make a matrix of the coefficients, like what we did here, where we made this matrix of the coefficients, like this negative 0.5 coefficient showed up here in this matrix or in this array. So we'll make that matrix of coefficients, then we'll solve for the best possible values using linear regression, and then we'll compare them to these offensive and defensive power ratings that we have up here at the top.